Okay, good afternoon, everybody here. This is Form 5 Thursday group. Okay, Form 5 Thursday group. So I think got some bad news for you all. Next year you'll go back to school as usual, right? 20th January when school reopen, Form 5 year to go back school, you know. Okay, and I just attended a meeting in the Japatan this morning. They all say next year when you all go back to school, there will be another programs, a lot of intensive course you have to go through last minute before sitting for your SPM. It's very important for you to go back to school, you know, when school reopen. Okay? So officially, your holiday only start after 18th of December. Okay? After 18th December, so you go for holiday, 20th January, you'll go back to school. Okay, so actually the Japatan already arranged a lot of questions. They already prepared question, ujian diagnostic for you all, you know. So immediately go back January, you have to do a lot of exercises last minute. Okay, last minute, prepare all of you, and then only start your SPM paper. Okay, so you still got a long time for you to prepare lah. So continue to work hard, okay? Don't stop studying, you know. From now until your February actually you all must non-stop studying You have to continue to study, okay? All right, Okay, now I want to start the lesson. I show you this. I show this paper. Okay, you have this paper with you all or not? I think this paper we haven't finished, you know. Okay, if we cannot see you, let me know. Okay, this question, have you finished or not? Can you look at, can you see the screen or not? Can you see the screen? Rian, can you see? Rian, can you see the screen or not?
Yes, sir.
Can Mafuza, can you see? No sound. Fu, can you see or not?
Yes.
Okay, can see that. Okay, come. Have you finished this question? Please let me know. Hey, someone please say something. Have you all finished this question?
Finish.
Finish,
11 no.
11 not yet.
Okay.
Okay, then we look at this question. Question 11. I mean, this group is slower, you know. Okay, come. This is a periscope using a prism. So we start answer question 11 now, Correct not, Elisa?
Yes.
Okay. So using a prism to reflect the light, go into the eye. So the eye see in a straight line. So the final image will be here. So this is the image, okay? Name the light phenomenon occur. Okay, here what happened? When the light, this one is a piece of glass, you know, prism. So the light go inside, reflect. So this is called what phenomenon? What phenomenon is that? Can you write the answer now? Fu, do you know or not? What phenomenon is this? The light reflected internally. What is that?
Reflection.
Not reflection. This one is a special types of reflection. Okay, yeah, someone answer here already. Che Fu Hao saying, okay, write the answer now. Che Fu Hao answer is correct. Total internal reflection. Total internal reflection. Please write the answer now. Because the light reflected inside the piece of glass, so it's called internal reflection. Total internal reflection. Okay. Total internal reflection. All right, next question. Two conditions for total internal reflection to happen. You still remember or not? In order for total internal reflection to happen, they must have two conditions. What are the two conditions? From 5 now, you remember or not? What are the two conditions? Okay, I want to hear from Chu Tong. Please answer. What are the two conditions for total internal reflection to happen?
From less than to denser.
Yes. Huh?
From less than to denser medium.
Kebalik, no, Chu Tong.
Huh?
Okay. First answer you write. Everybody write now. Light travel from denser to less than. Light travel from denser to less than. The light must move from denser to less than. Okay, see here now. Inside the class is denser. So the light move from denser want to go out to the A less than. But it cannot go out because it get reflected internally. So meaning that the light must move from denser to less than. Then only can happen one, you know. From denser want to go out to denser, so it get reflected. So first condition is light move from denser to less than. Okay. Second condition is what? One more answer is what? Anyone try answer? If you want to talk, you can type. Second condition is what? What are the, okay, come someone answer here. Let's see the answer. Jefu Hao again. This boy very good lah. Okay, Jefu Hao, good. Your answer is correct. Okay, so the second condition is the angle incident larger than the critical angle. Okay, second condition. The angle incident must be bigger than the critical angle. Okay, remember that these two. Can remember? Okay, come. I want someone to tell me the answer. Okay, Hui Xin, Yao Hui Xin, can you read out the answer again? So someone who missed it just now. What are the two conditions, Hui Xin?
The light ray must travel from a denser medium to a less dense medium.
Yes, correct. One more.
The angle of incident must be greater than the critical angle.
Yes, correct. Thank you, Hui Xin. Everybody got it already? These are the two conditions for light to experience total internal reflection. Okay, third. What are the advantages for using glass prism compared to using mirror? Okay, I tell you, this periscope is better, because this one is using glass prism to reflect the light. You can also replace the prism just by putting a piece of mirror. You put mirror here also can reflect the light. Mirror here also can reflect, correct? Not, but mirror not good compared to prism. Prism is better, The reason prism is total internal reflection. Total means 100% reflect the light. Perfect one. Okay. Whereas mirror, if you put mirror here now, mirror reflect only about 75% of the light. So no good lah. That's why we say using glass prism is better. Okay, the first reason you put there now. First reason. Image formed by glass prism. Okay, image formed by glass prism is brighter and clearer. Brighter and clearer. Okay, it's brighter and clearer because more light can be reflected. As I told you just now, total reflection 100% light reflect. So you have more light means image is brighter, clearer. Okay, compared to mirror, brighter and clearer image. Okay, another one. Another one. You write the answer first. Please get ready to write now. Glass prism periscope. Glass prism periscope does not produce multiple images. Does not produce multiple images compared to mirror periscope. Multiple images compared to mirror periscope. Okay, got the answer already? Everybody got the answer now? Okay, let's hear from Jolene. Jolina, can you read out the answer for the rest, please, Jolene? Jolina. Jolene no sound already, disappeared.
Yes, sir.
Jolina, can you read out your answer? Loud and clear.
The image is brighter and clearer.
First one. Second answer.
No multiple image form on prism telescope.
Yes, correct. Okay. Now I explain to you what is the meaning of multiple images. Okay, multiple images means at here more than one images or many images form here, so the image will overlap each other, so it become blur. This happen when you are using mirror. Mirror here, you will form multiple images. Okay, why? Because mirror can reflect the light from all direction, all direction from here, all can reflect. So because mirror reflect light from all direction, right? So it will form many images here lah. So it become multiple images. All the images are overlapping, so become clear, blur. But this prism, prism does not reflect light from all direction. It choose one, certain light only can be reflect. Because prism only reflect the light where the angle incident bigger than a critical angle. Bigger than critical angle, only the light will reflect. So good lah, understand? It doesn't simply reflect light. It only reflect the light. The angle incident bigger than the critical angle, because it must be total internal reflection. Total internal reflection means the angle incident must be larger than the critical angle. And meaning that prism select the light, not all the light can be reflect. Yeah, so this prevent multiple images to form. Understand? Okay, no eye, do you understand what I say or not? No eye?
Yes, sir.
And no eye understand? Okay, come, we
Okay.
move on. The next, B now. This question. Diagram shows an endoscope. Endoscope means you see the doctor lah. Doctor use this one, a wire, a camera, put inside the body of the patient to take pictures on. Okay. This wire is very good. This wire using fiber optic to put. Actually, basically, doctor can put this wire in any parts of your body. You can put in one to take video, to take pictures. Understand? And the wire is like that one. This wire actually very small, but we make it very big lah. So this is fiber optic. Fiber optic wire is like that one. Now you see now. It will send the signal in the form of light. You see, light. Light go inside the wire now. It will experience internal reflection. You see, all these are total internal reflection. Go here, reflect, come back. Here, reflect. All reflection happen internally. That's why we say this one reflection is total internal reflection. Okay, for total internal reflection means the light must move from tensor to less than. That means inside here, the inner core must be tensor. The outer core, the outer cladding must be less than. Because for total internal reflection to happen, right? Here must be tensor, outside here less than. So tensor to less than, so the light will reflect internally lah. So this will send the signal very fast, very clear, very sharp. So take pictures, take video very clear lah. And one more thing, this wire very flexible, not easy to break. That's why now the doctor can simply put inside your body. Very small, very fine, but it can send signal very fast. It wouldn't break inside your body one. You can bend it, you can coil it, it wouldn't spoil one. So very good quality. Okay, yeah. Okay, now we answer the question. You are asked to investigate the features of the optical fiber to design the endoscope. Okay, now we see now comparison between the reflective index inner and outer. I told you just now, right? Inner must be denser. Outer must be less than. Correct? Not just how I say one. You better remember, you know. Like someone didn't draw here. Who draw it? Don't do this kind of thing. Okay. Light must travel from denser to less than. From denser to less. So inside must be denser, outside less than. Okay. Denser here. This one only happen in this group. Yeah. Okay, I hope no more already. I stop it already. Okay. So my move from tensor less than, okay, so you know already, inside inner must be tensor, outer less than, okay. Now we answer the question. You must write it on a piece of paper, please, practice to write, okay. So comparison between the reflective index, okay, as you know, tensor mean bigger refractive index, okay. So meaning that the Ni and O, I is inner, O is outer. I think so supposed to be like that, inner, outer, isn't it? Inner and outer, okay? So, inner must be tensor. Tensor means reflective index bigger, so must be Ni bigger than No. Must be bigger, must be in these two already, okay? The inner one must be bigger than the outer one, okay, first one. Okay, what about the length? Length, you choose short one or you choose longer one, which one you choose? Which one you want to choose? Okay, come, let's ask. Every time I give answer only cannot. William Chen now only come in. William in already or not? Elisa Tan, can you hear me? You need to choose a long one or the short one. From here we know already either P or R. Then come here, you choose long. I think long only, no choice, right? Elisa, long or short?
Long.
Long, we choose a long one. Okay, both also long. Okay, longer because if the wire is longer means that the doctor can push it to a deeper area. The doctor still can reach, isn't it? So the wire must be long. The longer the better. If the wire is long, you can reach very deep inside and go inside. Okay. Okay, what about the diameter? Diameter, you want the wire big, you want the wire small. How do you think the wire want to big or become small? Belton, come out, please.
Yes, sir.
Belton, the diameter of wire should be big or small?
Small.
Yes, very smart, small. Why? What is the reason to small one? No, not. Why the wire must be small?
Can pass through small places.
Yes, correct. Because inside our body, certain places are very small, very narrow one, So the wire is small, the wire still can go through narrow space inside the body. Understand? Okay, last one, flexibility. Rihanna, what's your choice? Flexibility, high or low?
High.
Rihanna?
High.
High, yes, very clear already lah. So this is answer lah. Oh. Okay, now you write it. Use a paper to answer. You have to write it. Yeah, then keep the reason. Can you do it now, everyone? Cannot just listen like that. No, I'm not telling story. Yeah, you must write it down, you know. Okay, come, I show you the answer. The answer is in the Bahasa one, very sad. Okay, come, we go through. I use this one to explain to you. Huh? Okay, first one is N1 must bigger, Ni bigger than N. Oh, the reason is, okay, reason in English you write now, to ensure total internal reflection to happen. To ensure total internal reflection to happen. Okay. Bahasa we say pantulan dalam penuh mudah berlaku. In English is to ensure total internal reflection to happen. Okay. So when the line move from tensor to less than, then total internal reflection can happen. Understand?
Sir.
Why?
那个 N1 and N0 啦。
Uh,
If I write in the become the words become reflective index of the inner core and outer cladding like this I need to write in the words or just write a number like this.
yes, I encourage you all to write in sentence. Write in one sentence. Don't write use symbol like this lah. Try not to use like this unless you don't have time. Understand? So write in sentence. Like what you say lah. So write in a sentence. Okay.
Okay.
Okay. Understand? Okay. Now second one. Long. Just how you say we choose a long one, right? Okay, long one is in bahasa say boleh masuk jauh ke dalam. So you say in English can penetrate deeper into the bodies of patient. Can penetrate deeper into the body of patient. Okay, the wire long can go deeper inside. Can penetrate deeper into the body of patient. Yeah. All right, third one is small diameter. That's how we decided. We say small diameter, right? And then the reason is bahasa say boleh melalui kawasan sempit. So English is can penetrate narrow area. Can penetrate, still can pass through or can penetrate narrow area. Very narrow one also can go in. Yeah. Then next one is flexibility, kelenturan. Flexibility, high, we say. So you can say in English, can be bent, can be coined, you can coil it up, you can bend it, okay? Can be bent or can be coiled up without interrupt its function. You can bend it or coil it up without interrupt its function. The function still can on, no problem. And finally, you state your choice. The best is R. So you repeat all the reason now because it is Ni bigger than No, long, small diameter, and high flexibility. Okay, write all the answer. Okay, got it or not, everyone? Right, okay, you all must write, please, don't be lazy, take out a piece of paper, put in front of you, so you write it down the answer, okay? Ngô 要寫嘛? Ngô nấu sao ở đây kia đó?
有写。
要寫嘛? You are? Okay, come, next question. This one finish, everyone finish? Okay, next part of the question. This one. The light traveling from outside go inside the glass, right? This one is from less than to denser, okay? Calculate the refractive index. Okay, reflective index, what formula? Reflective index N now, what formula now? Okay, use this formula now. N equal sine I divided by sine R. Okay. All right, this formula. Okay. The angle I must be bigger one. So choose a 30 lah. 30 is bigger. Okay. Divide by R smaller, 18. So sine 30 divided by sine 18. So you get the answer lah. Refractive index sine 30 divided by sine 18. Huh? When you apply this formula, remember the I must be bigger. The R always smaller one. So your answer always bigger than 1. Because you take big divide by small. So your answer must be bigger than 1. Okay, that one is refractive index. Huh? Ngo, what is the answer? Ngo? 1.1.
1.62.
1.62. Okay, 1.62. Everybody got it now? 1.62. Okay, next. Critical angle. How to find critical angle now? Okay, the formula to find critical angle is this, right? N equal 1 over sine C. Okay. Now you want to find the C lah, critical angle. So you put sine C on top. Sine C equal 1 over N. Put the N over lah. Okay, and then you find the C. Okay. N is just now you got the answer 1.62, something like that, right? Okay, you put here, calculate lah. So what is the answer for critical angle? Now you see lah, huh? Okay, come. Just now 1.62, correct. Now, sine C is 1 over N, 1 over 1.62, so you get this answer, okay? Just now 1.62. Now you should get 38.12, okay? William Chen, got it or not? I'm William Chen. William Chen, are you there? Oh, no someone, I don't know. See, nobody answer me. William Chen got, got. Okay. Good, huh? Okay, next question. This Jocelyn say if I write in 3 decimal places. Okay, Jocelyn, no problem. You can write in 3 decimal places. Better, even actually your answer is more accurate, you know. Can, no problem. Then Li Ka Chuan say 38.17. Okay, correct. Li Ka Chuan, you are right. 17. So the answer not 17. Or 12. Li Ka Chuan, what's your answer? 38.17. Okay, 17 or 12. You all check lah. You all check yourself. You 3 decimal places. Okay lah. If you 3 decimal places is 38.17. Okay lah. If you use 3 decimal, so here is 38.17. Okay, thank you, Li Ka Chuan. Very good. Li Ka Chuan, I didn't see your name. Now you are hiding behind what name? Li Ka Chuan. Okay lah. Come next. This question is a good question. What will happen to the reflected ray in the prism when it strikes on YZ surface? Okay, now you see when the light go inside the denser medium already, from denser you want to go out, right? It's possible total internal reflection can happen one, you know, because moving from denser want to go to less than. Okay, you must check the angle incident. Draw a normal line, a normal like this. Calculate this angle. How big this angle? Calculate this angle. Can someone please calculate this angle? See whether this angle got bigger than critical angle 38 point something or not. Okay, 60, here 60. Okay, I cannot write like you're right, here 60. Okay. Then here, 90 minus 18, so here is 72, right? Then you can find here, then you know this one. Can someone please tell me how big is this angle? Someone don't want to talk, okay, 42. Lika Chuan again. Thank you, Lika Chuan. Very good. So Lika Chuan said this angle 42. Okay. 42 means bigger than the critical angle. No, critical angle just now we calculated 38 point something, isn't it? So when this angle incident larger than critical angle, that means total internal reflection happen, meaning that the light never go out. The light will reflect internally. So like that. It will come down like that, reflected internally. Okay. So the light reflected internally. The reason is incident angle 42 bigger than the critical angle 38.17. Understand? So your answer, you just write, because the question say what will happen, so you say total internal reflection happen. Total internal reflection happen because angle incident larger than the critical angle. Okay, that's all. Có the answer now? Chan Yen Wu, do you get the answer, Chan Yen Wu? Chan Yen Wu, got the answer or not? Chuang, do you get the answer? Chuang?
Yes, sir.
Okay. Chuang, can you read down your answer?
Total internal reflection happen because angle of incidence greater than the critical angle.
Yes, very good. Thank you very much. Chan Yen Wu, as you can hear, as you, okay, you. I don't know why you don't want to talk there. That's why I feel very boring teacher online, you know. God, always I call your name, call, nobody answer, but only a few can answer me. Okay. Okay, never mind. We move on now. Life goes on. Okay. Yeah. Next question. And now question number 12. This one I think is transformer question. Okay. There are two transformer here, P and Q. You study the transformer here. P stand for primary, S stand for secondary. Okay, you see here now. Voltage 240, input voltage here 240. This one by primary voltage 110. This one higher voltage, this one lower voltage. Okay, now, and the primary coil here got 2,000 coil, you know, but secondary coil only 500. Mean this one step down. This one step down because primary coil 2,000, secondary coil only 500 coil, so less coil, so it step down the voltage. Okay, whereas this one, primary coil 500, but secondary coil output coil more than 1,000 ton, so this one step up. Okay, this one will step up. This one step down, this one step up. Okay. Okay, now the answer, which transformer is step up? So your answer is Q. Okay, here Q. Q is step up. Transformer Q. Okay. Explain the working principle of transformer. This one don't know how many times already this question came out in the SPM. Come. Everyone listen now. You must listen, you don't listen to me, you cannot understand one, how this thing work, you listen carefully. I won't give you the answer, okay? You listen to me, then you write it down, okay? You write it yourself later on, you listen first. Okay, we name this one as primary coil. This one primary lah. Here output secondary coil. So you got primary coil, got secondary coil, isn't it? This one is a soft iron core. Do you remember soft iron core or not? Okay, now what happened is like this. When the input current come in, when the current flow inside the primary coil, when the current go inside, this primary coil will become magnet. It magnetizes. When this one is magnetized, the primary coil magnetized, the soft iron core also will be magnetized, meaning that when current flow into the primary coil, the coil and the soft iron core are magnetized. Okay, right? You write the answer. I wait for you, right? Cannot one. Okay, right. When current flow into the primary coil, follow. When current flow into the primary coil, the coil and the soft iron core are magnetized. The coil and the soft iron core are magnetized. Then next one, varying, V-A-R-Y-I-N-G, varying magnetic field is produced. Varying magnetic field is produced. Varying magnetic field is produced, and it link over to the secondary coil. It link over to the secondary coil. The magnetic flux cut over here lah. It will cut over here, but we don't say cut. We say the magnetic field or magnetic flux link over to the secondary coil. Okay. After that, continue to write. Change in magnetic flux. Change in magnetic flux happen in secondary coil. Change in magnetic flux happen in secondary coil. And finally, you write, when magnetic flux cut here, right? So you produce current. So you say, induced current is produced. Induced current is produced in the secondary coil. Induced current is produced in the secondary coil through electromagnetic induction. Induced current produced in the secondary coil through electromagnetic induction. Okay, remember now, the magnetic flux cut here, the cutting of magnetic flux, that is called electromagnetic induction. Okay, got it or not? Okay, come. Now I want someone to read your answer so that somebody never get one can. Okay. Chu Kai Ji, are you there, Chu Kai Ji?
Yes, sir.
Chu Kai Ji, can you read loudly your answer so that for someone never listen one? Okay. You read slowly your answer one more time, Chu Kai Ji.
When current flow into the primary coil, the coil and the soft iron core demagnetize.
Yes, correct.
Varying magnetic field is produced when it links over to the secondary coil.
Yes, correct.
Change in magnetic flux happen in secondary coil, and
Okay.
induced current is produced in the secondary coil through electromagnetic induction.
Yes, very good. But a bit too fast, Chu Kai Ji. you read very fast.
Okay.
It's okay. Thank you. Anyone didn't get the answer? Ngô, you say down mà.
Yo.
Say down Okay, okay. Noai, dapat ke tidak?
Yes.
Got all the answer now, Noai?
Yes.
Okay, okay, good. Some, we move on. The next one. This one is diagram shows a circuit consisting of a transformer. Here is a transformer, you see. This is primary coil. You can see the two lines here mean this is transformer. This one is step down, you know already. Here got more turns, here less turn. This is step down. Okay. Ammeter and two light bulb. You have two light bulb here, same one, you see, 12 volt, 24 watt, 12 volt, 24 watt, same one. Okay, now the ammeter reading here 0.5 ampere, here 0.5, and both the bulb light up with normal brightness. Okay, can you highlight normal brightness? What is the meaning of the bulb lighted up with normal brightness? What is the meaning? There is certain meaning here. No, you must know, what is the meaning of normal brightness? Chiu Tong, come out, please. Chiu Tong.
Yes, sir.
Chiu Tong, what is the meaning of normal brightness?
I forgot.
I forgot already.
Uh,
Li Ka Chuan, can you tell me what is normal brightness? What is the meaning, Li Ka Chuan?
So I also don't know.
You also don't know. Hanis ada sini ke tak? Hanis here or not? Hanis, I didn't see her name, no. Mungkin dia tak ada. Okay, someone type here, I see what he said. Harry Yong said, summer power, summer resistance. Half correct, Harry. You say summer power, summer power correct. But you say summer resistance is not correct. Harry, try again. You must know, this kind of question can ask one, no? Okay. Now Harry got it correct already. He say, this Jie Fu Hao even better. You see what Jie Fu Hao said? Receive require wattage. Yes, this is a perfect answer. When the bulb receive require wattage, means it will not light up normal brightness. Understand? You understand? Meaning that the bulb receive 12 volt. 12 volt. When you receive the required wattage, right? So it will work normally. It will light up with the normal brightness. Okay, please make a note here now. Normal brightness means the bulb receive the required wattage and power. Bulb receive required wattage or power. So meaning that when they get 12 volt, it will light up with normal brightness. Very good. Okay, Okay, now we answer the question. What is the output voltage? The answer to find the output voltage already here. Actually, I no need count. What is the output voltage? Okay, I will ask you. It's either you take 12 volt plus 12 volt 24, or you take 12, 12. So which one is correct? Only one is correct. You take both same 12, 12, or you end up become 24 volt. No I? No I now. Which one eh? You take 12 volt same, or you take 12 plus 12 become 24?
12.
No I.
12 volt.
Yes. It's 12 volt. No need add up because they are parallel. Parallel means same one. The voltage are 12, here also 12. So here also 12, same one. So no need add up because parallel. Okay, so here the answer is 12. Okay, 12 volt. Because parallel voltage are all same one, 12 volt. Okay. Then calculate the efficiency. Efficiency, how to calculate? How to find efficiency? Okay, efficiency, you take this formula. Efficiency is output power, PO. Okay. Divided by the input power, PI. Okay. Multiply 100%. That's the answer. Okay. How to find output power? How to find input power? Okay. Actually, very simple. It's already there. What is the output power? See here. Power is 24 watt. 24 watt. Okay. For power now, we don't care parallel or series. You add up one, Not like voltage. Voltage is parallel, same. If series, the voltage you add. But for power, never see series or parallel one. You add up all. So the output power here, input here is output now. So it's 48 watt. This is 48. Okay. So it's 48. The output power is 48. Then the input use VI to calculate P equal to VI. Take the voltage, multiply the current. Okay, voltage 240, current 0.5. So you put here lah. VI, okay. Input one is voltage current. 240. Wow, very difficult to write. Multiply 0.5. Okay, do yourself. Times 100. Okay, I don't write already. Okay. New, you are here, isn't it? New, can you come
Yes,
up, show your
teacher.
face a while? You, one, two. New, one answer. Can you calculate one answer? One answer, Lee? Huh?
40.
40%.
Yeah.
Okay. Who on? Okay, who on? Yeah. Hello, Mr. Lim.信有在啊，今天我签了哦，不过我回的时候 office 关掉，所以我留在我的房间，没有锁了。有那你是laporan什么 Mr. Lim 你讲？我还没有 check 应该是在 Dr. Alvin 他排在那边哦。那边那个 rack 那边你看有很多个发的，还有后面电脑的后面那边你找一下啦 Mr. Lim 啊。Okay, sorry. So Neil, you say 40%.
Yes, teacher.
Yes, correct. The answer 40%. Correct. Okay. It's 40%. Thank you. 40%. Okay. Efficiency 40%. Okay. Next one. Next one. This is an essay question. 10 marks question. Okay. Actually, not difficult one. You all must get 10 marks, full marks, everybody. You all must score one. This sort of question I must score. Okay, come. The transmission of electricity throughout the national grid network use high voltage. Do you remember or not? When transfer the voltage from one place to another place using the high cable in the jungle, right? They must use in high voltage. The use of transformer to step up to 400,000 watt. You remember or not? Step up to 400,000 watt one. Then only transfer from one place to one place. You are assigned to study the characteristics of a cable, or now choose only the cable, the wire. Okay, first, resistivity. How do you think? No. Resistivity, you want to choose high or low? โง่快点出来啊
Low.
low yes resistivity must choose a low one low resistance low resistance can reduce the power loss because resistance will cause a wire hot so loss in the power cannot so when resistance is low means can cut down the power loss okay the second one density okay come Farah are you there Faratina Farhan Hana something like that lah Farah ada gak no sound Aisyah I know you are here Aisyah where are you no sound okay now mai lah Lý Ca Chuan density you choose high or low Lý Ca Chuan density high or low the cable density high or low
Higher.
high density the high density then the cable become very heavy you know heavy
Oh, and low.
low density lah because this wire must be light because you need to hang very high in the jungle choose a lighter one lah low density okay what about cost cost must be low cost lah I think very common sense choose low cost lah low cost means you can save money right correct not okay and last is rate of thermal expansion what is the meaning what is the meaning of rate of thermal expansion Sung Ho Man what is the meaning Sung Ho Man what is the meaning of rate of thermal expansion Then no one answer one now. Okay, now my I talk only lah. I talk to the wall. Okay, okay. Rate of thermal expansion means when it get hot, thermal means hot. When it get hot, it will expand. When it cold, it will contract. This are not good, you know. When get hot, it will expand, contract. So the cable very easy to break. So no good. So we must choose low rate thermal expansion. Okay. Okay, so you know which one to choose already, okay, now you write it out. Okay, come. Okay. Low resistivity, first one. Okay, right? Low resistivity. The reason is reduce power loss. Actually, not kehilangan haba lah. You say reduce the power loss. Low resistivity, reduce power loss. Okay, the second one, low density, density low. The cable is lighter. Cable is lighter. Third, low cost, cheaper lah. Okay, low cost. So the answer is can save money, can save cost lah. Okay, menjimatkan cost, can save cost. And the last one, rate of thermal expansion must be low. Rendah is low. Low, So you say like this lah. The reason why it need to be low, you say the cable not easy to expand when it is hot. Cable not easy to expand when it is hot. Cable not easy to expand when it is hot. Okay, Then you state your choice. Then you repeat all your reason in English lah, Okay, please complete your answer. Don't be lazy. I know some of you sit down there, never do anything, just play your handphone. If Mr. Tam talk, let him talk, like you say, let him talk. Don't like that lah. You all must study, must practice lah. Be disciplined a little bit lah. You all Self-discipline is very important,
Sir.
May I ask you a question?
Can.
Yeah, because the cable queue is chosen, right?
What
Cable
The
queue, the cable queue is chosen, right?
uh-huh.
Yeah, and then the cost here, right, is medium. So in the suggestion, we write low or medium.
Okay, actually in these are questions we usually choose high or low one, no medium one. You cannot follow exactly usually like this one, no. There are only two only. This are question ask you to choose one. Normally you choose high or you choose low. Seldom we say medium one. Okay.
Okay, thank you,
So
sir.
you don't need to follow exactly the table You just follow, you just say only the cost must be low cost. Okay. Understand Jocelyn?
Understand. Thank you, sir.
Okay. Seldom we write, actually we never write medium one. For anything also we like either high or low. Yeah. Any more question? Rian, any question or not? Rian, you.
Sir.
Any question?
No.
No question. All very shy. All this fellow. Don't know why you all very shy one.
So, sir,
Yes? Come.
then in the queue there also write low because it has low cost.
Low lah. It's okay one. Medium also can consider low lah.
Okay,
Actually, the question is wrong, no. Not supposed to keep medium one. Okay, so keep low. Yeah, low or high only like this. So shouldn't give medium now. The question is wrong now, okay,
Okay. Thank you, sir.
Okay. Any more question to ask? Okay. Someone type here. Okay, what? Harry Young say rest for 5 minutes. Harry Young, you already rest for half an hour already. Still 1 5. Okay, rest 2 minutes can 2 minutes. You want to go toilet, you can go now. I can go drink water. Go toilet can go now. Okay, rest a while can. Okay, Harry, you can go and have a cup of coffee, then only come back. Okay, in your house, not go outside. Okay, come. Can everyone come back, please? Come back. Okay, come back. Okay, everyone. Okay, this paper, I don't know whether you all printed it out or not. Got print out or not? Actually, this paper, I already photostated. It's in the center, but not sempat to give you all already. CMCO close already. The paper is still in the center. Okay, like this lah. I already photostated the paper for those who put your name here one. I see is how many of them. I sent for photostat already this afternoon. So it's only 75. So I only prepare about 75 only. Okay. For the paper, usually I will ask you to come and collect on either Saturday or Sunday. Huh? No, which day you're convenient to come on? Saturday or Sunday? You need your parent to send you, right? Tell me
Saturday.
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 Besides any other? Everybody agree Saturday or not?
Yes.
Saturday
Yes.
most agree Saturday, Saturday afternoon or can not morning, afternoon.
Can.
So I put it Saturday more afternoon now. Okay. Okay, like this. I will put the paper outside the door. I put it on a table. On a table, I put the table outside. You all don't come into the center, like cannot come in, I will let you all to come in and later I can summon. Okay. You all come out one by one. You see got people went up already, so you all don't go lah. You all stay in the car, understand? You see like nobody already, then only you go down from your car, you go up. I will be inside, okay? But the paper will be outside the table. I will be sitting inside now. I can see you, but you cannot see me. I can see you all one. The door I open half lah, okay? So you take the paper and then you go down. So next one come, understand? So I photostated a lot, Actually, I spent about almost 500 ringgit, to photostat all the paper, almost 500 ringgit now. So you all must come and take the paper and make full use of it. Understand? Don't waste my money. Okay. I nearly paid 490 over. Okay, I pay already today. A lot of people already take one, Okay. So please, I will inform you the time. So I give about 2 hours, 1 or 2 hours time for you all to come now, so that you don't come at the same time, Because not only from 5, from 4 also, So Form 4 and Form 5 students, they will come together. Now, that's why I make the time longer. Okay? Longer, you all don't squeeze yourself to come at the same time. Okay? Form 4 students also, I put at the same day. Okay? Okay, come look at this question. Can you take out a piece of foolscap paper? I want to go to the experiment first. Question 3. Experiment question. Take out foolscap paper. You need to write the experiment. This one. Foolscap paper, please collect already. All right. Diagram show a boy skateboarding on 2 tracks with different height. You see here now. This one, the track is lower. Lower, you see that when he slide down, when he slide down, you can see the speed is very low. When he slide down from a higher place, right, you see the speed is very high. Okay. So you see here, slide down from higher place, the speed higher. When he's sliding down from a lower place, the speed is lower. Okay, meaning that in this diagram show relationship between the height and the speed. Correct or not? The higher the position, right? The higher the position, you will get greater speed. When the position is lower, the speed is lower. Understand? I talk to myself as usual now. Okay, come. First, please write the answer. Inference. What to write for inference? This I have to want to give answer already. Inference, how to write? How to write inference? Emily, go. Someone give the answer already. Ji Gang give this answer. He says speed depends on height. Yes, very good. You are correct. But your sentence too short, Ji Gang. You can write it longer, you say now. The speed depends on the height of the track. The speed depends on the height of the track. Okay, the track, T-R-A-C-K, track. Okay, the speed depends on the track. Speed depends on the track. Okay, got it or not? Okay, second one, hypothesis. Hypothesis, you must write the relationship already. Elisa Tan. Elisa, can you answer hypothesis, Elisa? Elisa lah. Emily? Emily 出来 Emily go.
The higher the track, the higher the speed.
Once again, Elisa, say it again. The higher the...
The higher the track, the higher the speed.
In hypothesis, we don't say higher the track now. You say the greater the height. We don't use a track anymore, you know, for hypothesis now. In front you can use. But when it comes to hypothesis, you have to write the theory now. So you say the greater the height, the higher the speed. Like that. Okay. The greater the height, the higher the speed. Yeah. Elisa, agree or not?
Yes, yes.
Okay, thank you, Elisa. Elisa Tan. Okay, next. You see here now, with the use of apparatus such as trolley, in your experiment, you must use a trolley. Use a wooden block. The function of trolley and the wooden block is for what, Nick? Given trolley, given wooden block. Okay, I tell you what. Come, I'll let you see the diagram. Don't draw now, just see only. It's here, no? The diagram is like that. So meaning that a wooden block is here. This is a wooden block. This is a trolley. Okay. So the experiment is using a wooden block. Maybe you use 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces to make it higher and higher lah. So meaning that you are manipulating the height. You control the height. You put 2 pieces, 4 pieces, 6 pieces, and so on. You're getting higher and higher, isn't it? Then the trolley go down. Okay. So you want to know the trolley go higher speed or slower speed, you see the ticker tape lah. Ticker tape, you can take out the ticker tape, you calculate the speed, isn't it? Right? You need to have a ticker timer, a power supply, ticker tape. When trolley go down, then you remove the ticker tape. I use a ticker tape there to calculate the velocity, calculate the speed. Understand? Okay, now you go answer 3-1. Aim. Aim is what? You're supposed to write the aim, isn't it? How to write aim? Aim is what? Aim of the experiment. How to write aim?
To investigate.
Full sentence, please. To investigate the relationship
between.
Look at the hypothesis. Between what and what?
Between the height and speed.
Yes, correct. It's between the height and the speed. Okay, between the height and the speed. Okay, variable. Variable now you have 3: MV, RV, CV. Okay, Jocelyn, Jocelyn, can you answer? Manipulated variable is what?
The height.
Yes, the height. Correct. You cannot write the height only, no. You must write the height, comma, H. Understand now? The marking scheme is like that one, you know. You put there the height, comma, H. Responding variable?
The speed.
Yes, the speed, correct. The speed, comma, V. The speed, comma, V. Okay, and then the last one is constant variable. This is the most important. In the experiment, just now you see the diagram, right? What must be constant? Okay, I'll let you see the diagram again. What must be constant? What cannot be changed?
The power supply.
Yes, power supply, the frequency of the power supply. And the frequency of power supply. And one more thing, more important one cannot change is what? Got one more thing very important one cannot change one. Is the, someone type here, I see what he typed. Yes, mass of the trolley. Yes, correct. The mass of the trolley must also remain the same. The mass of the trolley, okay? So you have two lah, frequency of power supply, the mass of trolley, and one more also very important one. Someone, can you please help me? What is that? It's something to do with here one. What is that? What must stay constant? 要回心，来，出来，要回心。
The length of the runway.
The length same lah, length must be the same, but one is more important now. Is the
Material.
condition of the surface area. No, sorry. Condition of the surface of the runway. The surface of the runway must be very important now. It's smooth or rough, must be the same, correct not? So you write conditions of the surface of the runway. The one must stay constant. Height of wooden block. Yeah, lah, for each wooden block must be the same lah, because you put 1, 2, 3, 4 pieces getting higher and higher, isn't it? Okay lah, huh? You know the answer already, all manipulated, responding, constant variable. Okay, next is apparatus. Okay, apparatus, you write yourself. Now, here you see the diagram here. Tiga tape, tiga timer, runway, wooden block, power supply, connecting wire. You must have the connecting wire here. Okay. Write out all the apparatus and material. Landasan is runway, tiga tape, tiga timer, wooden block, ruler. You need a ruler to measure the tiga tape, and power supply, connecting wire, and also a trolley. Yeah, and then pick out the diagram also, you know, arrangement of apparatus, okay, the diagram. Don't be lazy, understand? Use a paper, use a pencil, ruler, draw. Practice to draw. Practice make perfect, understand? Don't be lazy. I know some of you just take your camera, just shoot like that. No good, no like that. You're lazy, no. Lazy, then your hand, your hand become very stupid. You must practice your hand, practice your brain, understand? Self-discipline is very important now because online learning, the effectiveness of online learning is very much depends on the self-discipline, your own discipline. You must have a good discipline. Wake up early, attend the online class patiently, focus. Self-discipline very important, no? Okay, I tell you all. You don't stay home, you mind like that, cannot. Okay? You didn't go to school now, means your self-discipline become more important. Harry, ask him to stop. Ask him to stop. Okay, finish the diagram or not? Everyone finish, Jocelyn, finish drawing the diagram?
Not yet.
Not yet. Okay. Never mind. I give you a little bit more time. William, Harry, wait, don't play there, don't check too much lah. I focus lah, two of you. Next year, January, we all go back to school again. I'll see you again. The oldest Form 5 in the Malaysia history next year. Emily, next year 呢还要回去学校呢嘛？开学的时候要穿校服回去的，知道吗？
Yes.
校服不要丢掉，知道吗？开学的时候还要穿回去的哦。Okay, come. Procedure now, Okay. Normally, first step procedure. Okay, everyone follow, You write, number 1, the apparatus and material. The apparatus and material are set up as shown in the diagram. The apparatus and material are set up as shown in the diagram. Okay, number 2. Number 2, you start with this one 10 cm lah. You put one piece of wooden block. One piece wooden block is 10 cm. Okay, you start like this. So you say one piece of wooden block with a height 10 centimeter. One piece of wooden block with a height 10 cm is placed at one end. Placed under one end of the runway. Placed under one end of the runway. Okay. Third, the ticker timer is turns on. The ticker timer is turns on, and the trolley is allowed to move until the end of the runway. The ticker timer is turns on and the trolley is allowed to move down to the end of the runway. Okay, number 4. The ticker tape is removed You take out the ticker tape. The ticker tape is removed. And the speed of the trolley V is calculated. The speed of the trolley is calculated. You remove the ticker tape and then you calculate the speed of the trolley by using the ticker tape. Okay. Now use this formula, you can write it down. The speed is the distance divided by time. Distance of the ticker tape divided by the time. Okay. V equal to D distance divided by time. Okay. The speed is calculated by using the formula V equal to distance divided by time. Okay. Distance of the ticker tape, you can use a ruler to measure how many cm, then divide by the time. You see how many ticks. Okay. Okay. After this, what to do now? After you calculate the speed already, you already finished one set of experiment. So the next one is doing what? Next one do what? Ivish, can you come up?
Yes, sir. Yeah.
Next one do what?
Tabulation of data. Oh, wow.
Huh?
No. I repeat the experiment using a different kind of log.
Yes, correct. Very good. Okay. So next one you write, the experiment is repeated. The experiment is repeated by increasing the height by using increasing the height to 20, 30, 40, 50 cm lah. Okay, just now you said 10 cm one piece, right? Now you said 20, 30, 40, 50 cm lah. By adding more wooden block, okay? By adding more wooden block. The experiment is repeated by increasing the height to 20, 30, 40, 50 cm by putting more wooden blocks. Okay. Okay. Next one is your table. Table you can take from here. Now, translate yourself. Height here you cannot just write it. You must put height H. And then also must put put cm slash c. Very hard to write cm. And then here speed, put v and slash cm per second. Okay. Very teruk lah. H per cm, v cm per second square. Okay. Then here just now we said 10, not follow here lah. 10, 20, 30, 40, 50. Okay. Ours is 10, 20, 30, 40, 50. Okay. And finally is a graph lah. So the graph is here velocity or speed against the height. Don't make mistake. Responding variable must be here. Manipulated variable is here. So manipulating the height. So put the height here. Here the speed or velocity. Okay.
So
yes.
Use speed or velocity.
If you use speed, so you stick to speed lah. If you started with velocity, you use velocity. Same lah, it's the same.
Okay.
Here no issue saying that which one must be scalar, which one must be vector. No lah. In this case You can use speed or you can use velocity. Can also. Okay, understand?
Okay.
Who asked the question just now?
Chua.
Who?
Chua.
Oh, Chua. Okay. Okay, finish or not, everyone? Okay, we have one more question to go. Okay, now we look at question number 4. This one finish, Ngô, 完了吗?
Yes, 完了.
Okay, now we look at the next one. Question number 4. This one I think more difficult, this question. Right. Diagram show two identical remote control car. Okay, car A, car B, two same one on the track. Diagram 4.2, 4.3 show the cross sections of the motor used. Okay, the motor used okay, meaning that the motor is the one who make the car to move when the motor turn. How fast the motor turn. So you see here. So you have coil here, got wire, got coil. Outside here got magnet. Got magnet here. So meaning that inside here got current. You see current go inside the wire. So inside here become magnet. And then clash with the outside magnet. So you have magnetic force, isn't it? So this magnetic force will make this thing to turn. To make the toy car run because of using the magnetic force. Okay. This one, two magnet only. That's why the car moves slower. Whereas this car using 1, 2, 3, 4. 4 magnet. So the magnetic force is stronger. Stronger magnetic force will make this thing to turn faster. Turn very fast. That's why the car move faster. You see this car faster, this one slower, correct not? Okay. From this diagram, you already know that this one is something to do with the strength of the magnetic field and the force. It turn faster means it's a force now, correct not? So it's something to do with the strength of the magnet. When the magnet is stronger, so it will have a stronger force to push the car to move. So it's a relation between strength of magnet, strength of magnetic field, and the force. Understand? Jocelyn, understand or not? Jocelyn 你讲什么呢？
没有啊，那个不是我讲话。
Do you understand, Jocelyn?
Yes, sir.
Yeah, okay. Chua Guang Yao, understand?
Understand.
Understand, Okay, now first one. Inference. How to answer inference? I told you just now, right? Use a keyword depends. What depends on what? Chua, can you answer? What depends on what? Inference. What depends on what, Chua?
The speed of the car depends on the strength of the magnet.
The speed of the car depends on the strength of the magnet. Yes, correct. Okay, everyone can write. This one is in front. In front, you can write what you see. So you can see, you write like that. The speed of the car depends on the strength of the magnet. For in front, you can say the speed of the car. The speed of the car depends on the strength of the magnet. But when come to hypothesis, I cannot already know. Hypothesis, you must write the theory. In magnetic, you learn is a relationship between the strength of the magnet, the magnetic force, right, with the force relation. Okay, if you are not sure now, okay, now you answer the hypothesis first. Okay, hypothesis, okay, come, I ask someone to answer. Chan Wen Kang, are you there? Chan Wen Kang? Chan ah? Chan can come out or not? Chan cannot talk one. Chan, hypothesis, can you type out hypothesis, how to write? Liao Xingxiang,来 hypothesis. The stronger the strength of the magnetic, the strong, like come what he wrote, the stronger the magnet, the higher the speed. This one is Wen Kang one, half correct only. Okay, you know why I say your answer not fully correct? Because Wen Kang is saying that no, the stronger the magnet should be the higher the speed. But wait, why? I tell you why the reason. Okay, you see the next one. The next one, they give you the apparatus is a C-shaped iron core and the copper rod. They give you these two things, So meaning that these two things is nothing to do with the speed already. Okay. The C-shaped iron core and the copper rod is for you to do this one. Come, I show you now. Now you see. This one is a C-shaped iron core here for you to put magnet one. And then the copper rod for you to put here. Put it here. So in this thing you already know one you learned before, right? When you on the power supply, this copper rod will either push in or push out. Correct or not? Push in or push out is the force now. When the force stronger, it will push further, the distance move further. Okay, this experiment is like this lah. The magnetic field, right, you can control. You started with put two pieces of magnet, one piece here, one piece here. Okay, then you on the power fix lah, the current. Then you see how far this rod, copper rod push here. Okay, you measure push here. Okay, you measure the distance. Okay, after this, you make the magnet stronger. You put two pieces here, another two pieces put up. Now 4 pieces already. So the magnet becomes stronger. When a magnet getting stronger, you on the same power, you see this copper rod will push further. Then you measure the distance. So meaning that in this question, we are looking at the strength of the magnet and the force, in the force, or we say the distance moved by the copper rod, not the speed. Wen Kang, do you understand now? And Wen Kang, understand ma? Okay, thank you, Chan Wen Kang. That's why I tell you the technique like this, If you are not sure what hypothesis to write, to confirm it, you go to section C. You see what the apparatus given. Because from the apparatus given, you already know the experiment need to do what. It's very important. I always encourage my student before write your hypothesis, you go to section C. You see what apparatus given. From there, you can confirm the experiment is what. Because apparatus given is very important. Yeah. So now the hypothesis should be the stronger the strength of the magnet, the stronger the strength of the magnet, the stronger the force. Okay, the stronger the force. Nói in bahasa say semakin bertambah kesan daya, the force stronger lah. Okay. Yeah, the stronger the force. All right. Now aim. Aim is to investigate the relationship between blah, 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 blah. You look at your hypothesis. Okay. To investigate the relationship between the strength of the magnet and the force. Then manipulated variable. Okay, now you see yourself here. In Bahasa, I think everybody can understand Bahasa Melayu one, isn't it? Manipulated variable, numbers of magnet, bilangan magnet, numbers of magnet. How many pieces magnet you put there? Okay, the more magnet you put, the stronger lah. And the responding variable, distance moved by the copper rod, comma T. Distance moved by the copper rod T. And the constant variable, current. You see, arus mean current lah. Okay, current. Okay, then a list of apparatus. You can see the diagram. Now, from the diagram, got already. You jot down. C-shaped iron, magnet, copper track. This one copper track. This one copper rod. Copper track or copper wire also can. Okay, this one copper wire also can. Ammeter, dry cell, rheostat. All this, you need a ruler to measure the distance. You need a ruler. Okay, after that, draw the diagram. Wait, practice to draw. Don't be lazy, understand? Perry Young, are you there? Perry Young, William Chen, are you there? Practice, practice draw now. Don't be lazy, William, draw the diagram, William.
So what do you say?
I said don't lazy. Draw, understand? Take a piece of paper, draw. Got draw or not?
Now drawing way.
Draw,
William see TikTok lah, you cannot lah.
TikTok your head, don't see TikTok mà. Okay, another 2 minutes. Okay, finish. Draw the diagram. Draw nicely. Okay, label your diagram. Okay, finish or not? Okay, come. I think finish now, huh? We go procedure now. Chuang finish already or not? Chuang?
A little bit more.
A little bit more. Okay. Liao Xingxiang finish or not?
Yeah.
Done.
Done.
Okay. 1 more minute, huh? Some I think not finish yet. Let them do first. Lim Xiaohui, are you here? Lim Xiaohui,
Yes, sir.
finish already or not? Lim Xiaohui,
Yes.
finish, huh? John, have you finished?
Yes, sir.
Okay, come lah. We start with procedure now. Okay, first procedure always the same like you right now. Apparatus material are set up as shown in the diagram. The apparatus and material are set up as shown in the diagram. Okay. Second step you must say now. 2 pieces of bar magnets. Use 2 pieces lah. 2 pieces of bar magnet are placed on the C-shaped iron. 2 pieces of bar magnet are placed on the C-shaped iron as shown in the diagram. You must say how you put the magnet here to say that shown in the diagram. No? And then the current is fixed to 1 ampere. You must fix the current. No, use a real start to fix the current now. The current is fixed at 1 ampere, and the current is fixed at 1 ampere, and the switch is turned on. And the switch is turned on. After that, do what? Fix the current, put the magnet already on the current. After this, you do what? Mahfuza. Mahfuza, can you come up, please? Now you do what? Mahfuza?
Yes, sir.
Now you need to do what? You on the current already. After that, now you need to do what? After you on the current, the copper rod.
The copper rod need to.
The copper rod will move, isn't it? The copper rod will move. Then you measure the distance moved by the copper rod. Understand? Now you say like this. The distance moved by the copper rod is measured using a ruler. The distance moved by the copper rod T is measured using a ruler. Yeah. Okay, so we have finished one round of the experiment already. Next one is repetition now. You repeat now. Okay, I want someone to tell me how to repeat the experiment. Lim Xiaohui, can you say or not? Can you tell me how to repeat the experiment? Lim Xiaohui, say slowly. Lim Xiaohui, 慢慢讲. How to repeat the experiment? How you repeat that?
Repeat the experiment
The experiment is repeated by
by increasing the number of bar magnet, which is
you must say how many, you know. You must say
4
correct.
pieces.
What you say is correct lah. Okay. Okay. Can you say it one more time, Lim Xiaohui?
The experiment is repeated by increasing the number of bar magnet, which is 4 pieces, 6 pieces, 8 pieces, and 10 pieces.
Yes, very good. Okay, that's the answer. Nah. The experiment is repeated by increasing the number of bar magnets to 4 pieces, 6 pieces, 8 pieces, and 10 pieces. More and more. And that will be your procedure. Okay. Everybody got the answer or not? Hui Xin, do you get the answer?
Yes.
Got it, Elisa Tan got the answer or not?
Yes.
No I? Do you get the answer? No I?
Yes.
Yeah. Mafuza got it or not?
Yes, sir.
Got okay.
So
Yes.
can I just add 1, 2, 3, 4 piece?
Okay, one piece, one piece, how to put that? It must be balanced, one up, one down, one, you know. It must be odd number lah. 2, 4, 6 like that. Understand?
Oh.
You see the diagram, one up here, one down here. Magnet, you cannot put one piece one. One piece no function one, you know. You have put 2 pieces. You must have put one north, one south. Must be one pair one. Then only you have the magnetic field one pair, north, south. So you must have 2, 2, 4 like that. Okay,
Okay.
So I understand?
Understand.
Okay, okay. Come. The next one will be tabulation. Okay, table. Table, this one okay, you see yourself. Okay. So here is number of bar magnet N 2, 4, 6, 8, 10. No? And then distance moved by the copper rod. You must have T/cm. Distance moved by the copper rod. And last are the graph. The graph is wrong, you know. The graph is wrong. Okay, this one cancel. This one is wrong now. Can you tell me what's supposed to be here? What's supposed to be here? Here must be the responding. Responding is the T. So here's supposed to be T distance. Okay, T/cm. Okay. Here's supposed to be a number of magnet N. Okay, like that. Here's supposed to be the distance moved for the copper rod. Here is the number of magnet. And only correct now because you are manipulating the magnet. Responding is the distance. Here the answer given also can wrong one, no. Okay, finish. A little bit more, I want to continue. Okay, extend a little bit. Never mind. Okay. Finish, everybody? Question finish or not?
Finish already.
Okay. Okay. Okay, come. I just want to do a little bit more parts. You look at question number 1. Question 1. The vernier caliber one. Okay. This question is something to do like this. You study the relationship between the pressure and the force. Okay. So I think it's this force and pressure, right? So here using the 100 slotted weight. So you increase the weight here. 100 gram, 200 gram, more and more you put here, right? So you see what happened to the pressure. Force is here. This one is force. The weight, 100 gram, 200 gram, the one is weight, force. Pressure is here. How deep you go inside the plasticine. This thing will sink into the plasticine, isn't it? So how deep you sink inside, I use a vernier caliper to measure. Understand? So the reading is like this. Okay, now you can get the reading. Okay, first one is 0 error. You see, nothing here now, but the 2 0 are not pointing to each other. I mean, got 0 error. So this 0 error is negative 0 error. Okay. Why negative length? Still remember or not? 0 error got negative, positive one, you know. Because this 0 in front, this 0 behind. When this one overshot already, overshot in front, so it's negative 0 error. Negative, and you see the line, this number there, this one, up and down same. This one is line 5, 6, 7, 8, so it's 8. But the 0 error, if negative, you cannot read the number straight away. You cannot say negative 0.08. No, it's wrong. If negative, you have to take 10 minus 8. 10 minus 8, you know. Minus from 10, if negative 0 error. This one in front, this one behind is negative. If this 0 is behind, this one in front, then it's positive. Positive, you read the number direct. But if negative, you minus from 10. 10 minus 8 is 2. So the answer 0 error is negative 0.02 cm. Negative, this 0 error is negative. Remember that, This one longer than this, okay? Negative. Okay, now first diagram. Can you read? This one you put 1 Newton, the first 1 Newton. What is the reading? 0, 0.1, 0.2. So here is 0.2. It must be 0.2 something now. Which line same? Okay, this line, line number 6, right? So the reading you read direct, no? 0.26. Here, 0.26. Okay, then T, do the correction. 0.26 minus negative 0.02. Got 0 error, so you need to do correction one, 0.26 minus 0.02 become plus. So become 0.28. Like that. Okay. The rest of diagram, okay, you finish it up now. Okay, do this one. Later, I'll let you see the answer. You do first, okay? Right here. This one what, this one what, this one what, this one what. Here, 0, 0.5, 0.6 is 0.6. I think I'm 0.6. This one. 0.60 like that now. Here 1 point something. 1 here is 1 point something now. Yeah, write the answer here now. Or Hui Xin diagram 1.5, what is the reading, Hui Xin? Not there already. Rian, are you still there?
Yeah, sir.
Rian, can you tell me this is what answer?
0.60.
Yes, 0.60. Then after do correction become?
0.62.
Yes, correct. That diagram name 1.6, this is what?
1.04.
Yes, correct. After correction?
1.06.
Okay, very good. Okay, we end. Thank you. Okay, next, this diagram. Liao Xingxiang, this one what answer? Liao Xingxiang?
1.49.
1.49. Yes, correct. After correction,
1.51.
Yes, very good. Okay, thank you, Liao. Okay, last diagram. Jiu Tong. Jiu Tong. Last one is what? This one is what reading?
1.85.
Yes, 1.85. After correction?
1.87.
Yes, correct. Okay, now you check all your answer now. Now it's here, okay? The original reading, after you do correction, you get this one. Yeah. Okay, the rest of the question, you all do first, do at home, okay? After you have the table, you plot the graph and answer the rest of the question, okay? So I think for today, I stop here, Okay, let's come back here. Okay. Remember this Saturday afternoon, I will tell you the time, what time to come and collect. Must collect the paper because I spend a lot of money to print already one, you know. You don't come and take, then I will throw the paper wasted, okay? So thank you, everybody. Thank you very much. Follow the lesson until now, okay? And remember, take good care of yourself. Stay home. Always stay home. Stay safe, okay? Take good care of yourself, okay? Bye-bye. I'll see you again. Bye-bye.
Thank you, sir.
Yeah, bye-bye.
Thank you,
Yes,
sir.
bye-bye, bye-bye.
Thank you, sir.
Bye-bye.
Thank you, sir.
Okay, bye-bye. All right, bye-bye. Okay, bye-bye.